In this unit, we'll talk a little bit about how chemistry fits into the general field of science and specifically how the scientific method works. Both chemistry and physics are considered physical sciences and are very closely related to one another. They both involve the study of matter. Turns out that matter is any object that has mass and occupies some volume in the universe. So there's nothing different about that to make a distinction between chemistry and physics. But chemistry deals with the transformations of matter, and that's a key word. The transformations are either physical or chemical changes that alter how the atoms in a particular substance are interacting with one another. In physical processes, the actual molecular units are not changing, but how those molecular interactions occur and the phases of matter that are involved are crucial. Whereas in chemical changes, the molecular units are changing significantly, and so how the atoms within that molecular unit are attached to one another are altered in some way. Science is a field of study that involves the logical understanding of the world and the universe around us. Chemistry is a form of science, and it relies heavily on the logical processes that are inherent in philosophy. Turns out that all scientists rely pretty heavily on what's called the scientific method, which is a very systematic way of understanding and testing your understanding of these processes. Some vocabulary that you need to be familiar with. Initially, you're going to make an observations of something that is usually unusual or slightly different than the common things that would be normally observed. And so after you have an observation of some sort and you recognize it as being important, you then have to come up with some sort of hypothesis. A hypothesis is a possible explanation of the observation. This is often based upon your experience. And then thirdly, we have an experimentation. Experiment is something that is done to test the hypothesis. Designing good tests or designing good experiments is a crucially important part of the scientific method. And then finally, after much experimentation, the hypothesis may evolve into a theory. A theory is a well-tested explanation of the observations. If there is little doubt that the theory will ever change, that theory may actually become what we refer to as a scientific law, which gives you great predictive power. The scientific method is a series of steps that are used to understand the world and the universe around us, typically starting with an observation. Once you've made an observation of some sort, you will do some sort of analysis. This analysis may be based on your previous experience and the understanding that you have of scientific laws, and this then allows you to develop a possible explanation, a hypothesis. The analysis may also be just purely speculation on your part, and so may not be consistent with the scientific laws. Once you have a hypothesis, however, you then have to test that explanation by doing an experiment, designing good experiments to understand how to come up with reasonable explanations is really, really important. That then can cycle back to making further observations as a result of doing the experiment, which then leads to either supporting the hypothesis, or if the hypothesis is not supported, then you may have to revise the hypothesis and do further experimentation, and repeating that process many, many times, getting other people to test your hypothesis using alternative experiments. And then after many, many people have tested this, it may become a theory, and then cycling back to ultimately becoming a scientific law.